Right, so this is going to be part of a series of movies explaining the process that I'm using to export data from an animation package such as Maya. So here, for example, we've got a simple animation rig of this very simple shark model with some bones through it, and then you can see it's had a few sine waves added to it to make it move. And what we want to do is to get this basic data out into another package to use it, for example, in a real-time program to maybe go through and do some other effects on it, or maybe just use it as some basic animation in the system. So to do this, we use a system that we call point baking, which basically allows us to grab each of the vertices of this mesh and its current position per frame. So as we sort of move along the frames, you can see that some of these, well, all of these vertices positions change. And we're going to export that into some sort of file format that we can then use and load into other packages. And whilst I'm going to demonstrate doing this in C++ code, I have got scripts which will allow us to import, for example, into XSI and also into Houdini from Maya and vice versa. So the first thing I'm going to talk about is the point bake file format. So for simplicity, this is exported as an XML file. So whilst it's incredibly verbose, and in this case for that animation cycle you saw there quite a large file, it's 138,000 lines long, it does allow us to read through and debug it quite easily. I do also have binary versions of this as well, but for now we're going to stick to the text version. So first we have a standard XML header, then we have the tag to say it's an NCCA point bake file. We've got a few outer tags which just sort of set up some details about what's going on. So the name of the mesh that's been exported. Most of my code doesn't use this, but it's there. The number of vertices in the mesh. Now at present this is designed to only work with meshes that have the same number of vertices per frame. So anything that's smooth skin that may change the amount of vertices in our mesh will not work. We then have start frame, end frame, the absolute number of frames, and then at the moment, again, this is here for later work, but the translate mode is in this case set to absolute. I'll talk about this in a little while. Then per frame we have then a list of the vertices as they appear when they're saved out in the mesh. So for example, vertices 0 will be the 0th vertex in the OBJ file, then the first one, second one, and so forth. And we've got an attribute. In this case it's going to be translate. At present I'm only exporting translate data, but it's allowed for us to extend so that we could, for example, export rotation, scale, and other examples if we need. So this is very much just a working framework. So frame 0, vertex 0, this is the data for translate, and this is basically the absolute position of that vertex at that frame. And if we go to another frame, we'll see that go per frame. Oh, stop doing that. Go away. Wrong key. Frame number 1, frame number end of frame number 2, 3, and so on. So you can see that these data values change their position per frame as we go through. So very verbose, but obviously very easy to debug, very easy to use. So step 1, what we need to do is to write out this data in this format. And to do this, there is a series of Maya Python scripts to do it. So basically we've got, and this is available on my website, I'll post a link, a series of functions. This is the point bake function here, which we'll go through and write out all the data in the XML format. It's fairly simple code here, and there's a nice little UI for it as well. So if we just quickly paste that into Maya there, and point bake export, run, you see that we've got a nice little UI. It picks up the start and the end frame from the current time bar. All we need to do is to select the mesh that we want to export and then give it a name, shark2.xml, and you can see it's going through. This can take some time if you've got quite a large mesh. Obviously this is typically used for smaller meshes and for getting data in and out, for doing other simulations and things like that. There are obviously other methods to do it easier. So that's the end of the first part. What we're going to do next is look at how we load the code, and we can then load that using C++. Before we go, there are two methods of using the class for point bake. One, we can just load in the data and get the raw vertex data and create the meshes ourselves. The second is we can actually attach a mesh to the point bake data and use that existing mesh. And in that case, the mesh we will need in a format that the NGL library can read. So in this case, what we're going to do is to export selection, and we're going to export it as an OBJ, and I can just call it shark_try.obj, which will export that file as an OBJ file, which we can then later load in. If you don't have the OBJ exporter in your menu, go to Plugin Manager, and you should see it down the side here somewhere, OBJ exporter. There it is, OBJ export bundle. So just choose that, and then it will be there.